would say, objectively bad habits. Just kind of like passively studying, just being inherently inefficient, and like a few other issues that are common with undergraduates. But anyway, I'll get started. There are three typical issues.
Sorry to interrupt, but
Yeah.
do you mind if they interrupt you with questions?
Yeah, of course. Like, feel free. Feel free to
Or save them
ask
till the end, either way.
Yeah, I can clarify any of the content that I'll be presenting today. But there are three basically pillars or issues with mastering material. One is just rapid forgetting. We all tend to forget, of course, but just especially with getting so many like concepts, like in chemistry, organic chemistry, especially inorganic chemistry as well. You're just flooded with a whole bunch of concepts, and you're expected to retain all of these without cramming, and then have them for the near future and in the distant future as well. And then passive studying, kind of just, this is the concept where you don't really study as effectively as you could. You just kind of go through the material a little bit lax and not actively retaining this material. And then third is just typical reversion to past behaviors, subconscious tendency to revert back to like what you've done originally and like subconsciously refusing to take on new material. But solutions to these are active learning and spaced repetition. Spaced repetition is a subset of active learning, but it is perhaps one of the most important aspect of active learning. And so active learning, of course, is less comfortable. You're basically engaging more with content, engaging more with the material, as well as like doing practice questions, etc. But active learning actually yields a better studying and test result. So if you actively learn as opposed to passively learn, statistics have shown to actually improve grades, improve retention, and then improve overall success and efficiency. And passive learning is essentially the opposite. Yes?
Can you clarify by like less comfortable? So are you saying
Yes.
that even though you don't feel like doing it, you should just do it anyway?
That is one of them.
Okay.
Yeah, I'll also be talking about study techniques regarding that, but less comfortable in that it takes more, I say, brain power and like more dedication, as well as just more like motivation to do it in general. Because passive learning, I'll get into it a little bit more, but passive learning is essentially just reading the textbook and going over materials, perhaps highlighting notes, but that's actually not active learning. So active learning is more the approach of understanding each fundamental concept, building questions off of that, like asking yourself questions, testing yourself with questions, and then perhaps like drawing it out, using diagrams, synthesizing like the material, organizing it according to how you learn the best, and then applying that information. So it's a huge like list of steps that is proven to be like far more effective for most students. And so active learning methods, I've said before, there's self-testing, there's spaced repetition, but the three other ones I'll discuss are just time management, writing versus typing, and drawing. Drawing is like a wonderful way to actively learn. But start with self-testing, of course, you do practice problems, you do practice exams, that is a standard. These are, of course, kind of mimicking the testing environment you will have for a midterm or final exam. Time management, although it's not specifically a learning method, it, of course, helps with all learning methods in that you can spend more time like doing something that you want to do if you study more effectively. Because when you study more effectively, you learn more like under a time crunch, and then you can go do the things that you want to do. Say, for instance, like go play hockey with your friends or just go out to the mall. So you have more time to actually do the things you like to do. Spaced repetition, I'll elaborate on this concept because it's perhaps like one of the pillars that I stand by. But when you have a concept and you apply it and you start to learn it, you have about a day or so where you do understand the concept, but not necessarily retain it. But if you study that, like within that 24-hour period, you are probably going to retain more of that than you would otherwise. But in about 3 days' time, there's a drop in like how much you retain and how much you understand of that concept, and that's recurring. So if you do spaced repetition, if you space out like studying this concept one day, and 3 days later you study it again and do more practice problems. Like 5 days later, do that again. That's one way to have like about statistically 40% increased retention of the material. So that's honestly where most people fall short. I know I've fallen short doing that, and that's why I harp on it so much. But writing versus typing, of course, like I don't see any computers out, which is wonderful. It makes me happy because writing engages like your motor skills as well as like your cognitive engagement, and so you have more retention just by writing for most people anyway. But some people prefer to type. It's just word for word. You can get that with typing, but with writing, it's slower and you have to synthesize information. So you can't write everything the professor says, but rather you synthesize it into something that you understand, some words that like come from like your own vocabulary. And then drawing, of course, if you're drawing diagrams, for instance, like stoichiometric ratios to organic chemistry, like maps and processes to like biology, it's drawing that also really helps like ingrain concepts and fundamental like just concepts in your brain anyway. But on spaced repetition, this is the learning curve I was talking about. So like immediately after you learn it, you are supposedly going to have 100% retention rate, and then that gradually like decreases. In about 3 days time, you may remember it, you may not remember like the full details of it, and so that's why first, second, and third review are spaced out at certain time intervals. So with those specific time intervals, you can like restudy it, and then eventually, like if you kind of look at the slope, if you have taken calc before, you kind of like take the derivative, that's going to be the steepness of a certain line at an instantaneous point. And so if you keep looking here and here and here, like if you study it and like the line goes back up, that also kind of straightens out a little bit. So you have longer retention, and that's of course like helpful for the final exam, for a midterm, because you're not just cramming everything into one session, you're actually going to remember it for the long term. And then, so there's 4 steps to active learning. Step 1, identify. Step 2, organize. Step 3, memorize. And step 4, apply. And we'll begin with step 1. So essentially, with this one, this is going through the book, identifying major concepts, anything that's bolded, italicized, or any other fundamental concept that would otherwise be important to the class. And so, say for instance, you can take chemistry in general and divide it into subsections like inorganic and organic. Go into inorganic, there's gas laws, there's stoichiometry, there's bonding. So these are all central concepts that branch into, like, of course, another subsect of concepts. But once you identify these and you find the inner workings of each and every one of them, and you actually understand the fundamentals behind each concept, that's when you can start to like move to step 2. And that's organizing and synthesizing. So you take the information, so you have, again, we're going over stoichiometry right now, so we'll take stoic. So you have grams, and then the grams to mole conversion, and the moles to mole conversion, and then you can go from there to like, you can use that in gas laws, or you can take it another path. And so mapping that out and understanding the relationship between those is essential, and organizing this in a way that's kind of fit to you is best. So say for instance, you can diagram this, you can like make a concept map and like see how stoichiometry works in general. But this is also applicable to like other aspects of science, such as biology. You're doing hand-drawn diagrams, or say for instance, you want to know how cyanide inhibits metabolic processes. You can also diagram that, and that, like, just drawing it out and understanding the concepts behind what you're talking about and like what is asked of you is honestly one of the pillars that upholds like a lot of the study habits we should have. So step 2, again, synopsis of this is organization and synthesis of your information in your own words. Again, putting it in your own words is honestly one of the best things you can do. But of course, we still have step 3, and that's memorize. And memorization, of course, it takes time, and it's essential to like most everything we do, because otherwise we wouldn't understand a lot of what we learned anyway. But memorization and retention in this aspect, especially while studying, is crucial to specifically the sciences, because not only are you taking information and you have to recall it, but you can apply that information later down the road. That's why we have like prerequisite classes. So we learn generalized material and then go more in depth on these concepts. But if we don't have those concepts memorized and understood in the first place, then how can we like keep on going? How can we keep on progressing? So mostly memorization is best done by writing out things. So like you can type stuff on your computer, you can make a Quizlet, of course, but flashcards are honestly also where it's at anyway. And then spaced repetition is also very helpful with this, because you do like refresh all the concepts, go through practice problems, etc. And that just the continual repetition of material and concepts and just learning in general will definitely help you memorize a certain fundamental concept. And then the last one is applying your information. So this is perhaps one of the, I would say, essential steps. Like, of course, each step is great, but most people stop at memorization, so they don't actually go into application all that much. So, of course, practice exams or practice questions, or in in our Gen Chem book, we have those assigned homeworks. So that is also an amazing tool to use. But just as a generalized question, who goes back and does this dynamic study modules after you've done them on like Sunday? Okay, that's good. That's honestly really good. But it's also kind of and a little bit of an eye opener. Like if you don't do that, that is a studied resource you can use for all the exams. Like every single Sunday, it's going over so many concepts that you've learned the past week. That's basically a synopsis of what you've been doing, and that's also that's honestly just so great. So I don't know, I'm ecstatic about that. But just practice questions, practice exams. I didn't talk about the Fineman Technique. The Fineman Technique is essentially taking a fundamental concept and saying, okay, so we have this fundamental concept. How do I explain this to someone my level? How do I then like write this all down, and do I understand it? If yes or no, then like if no, go review it again and then try to make it into your own words so that someone on your level could understand, and then take that and bring it down a notch. Who like try to talk to like a high school student, or just pretend to talk to a high school student? How can I simplify this information and synthesize it into something that is like so much easier to understand? And then take that a step further. Can you explain this to a middle school student? So it's taking this information, making it into your own words, and then taking that and reducing the complexity of it. So if I say, for instance, take a biological pathway, sure, it's a lot of steps, but also I have to explain what, say, like a proton gradient is, or what a certain protein is, and just take that and kind of just make it so simplified that almost anyone could understand it. And then again, the like kind of mentor-mentee technique regarding teaching is also just ingrained in Fineman Technique, because you're teaching, if you can teach the material, you honestly know the material. There's no doubt about it. And then I'll just like talk a little bit regarding my current schedule and just the general trend regarding like an undergraduate. So sometimes, we have like unconscious inefficiency. We're either on our phones, we're on social media. Of course, that's like harped on, but just doing nothing in general, that's also an unconscious inefficiency that we have. A lack of direction. Some people say we don't have enough hours in the day, but honestly, if you are the most efficient, like as you can be, you're gonna have so much more time to do the things you actually want to do. And So by actively learning or actively studying, you learn more material in less time, and then by doing that, you have more time to do other stuff that you really want to do. So I'm just gonna like kind of take my current schedule. I typically try to get up at like 5 or so to go work out or study material before class. So of course, not a lot of people like to wake up that early. It's really hard waking up that early, but also like sleeping is also key, I would say anyway. But just taking one quick look at my schedule, I have like Sattler's chem class, I have leap class, and everything that goes until usually about 5 o'clock each day, or like give or take anyway. And so from 5 o'clock to 10 o'clock, I have like 5 solid hours that I can use either to get dinner, to study, or do some other things. But that's, of course, subject to change if something happens. So studying effectively, even if you have a more rigorous schedule than this, if you have more work to do, if you have like other things that are conflicting, studying more efficiently will not only like decrease the study time you have in general, but will also increase the opportunity for sleep, increase the opportunity to go out and do the other things that you like to do. So on the weekends, I'm also on call for my department, so I can be like called in at 3 a.m. or be called in at like 9 at night. So during that time in the day, let's say I have a research paper to write, or I have like 3 lectures to go over, I can take that time and like crunch it down and then get everything done within maybe like 2 or 3 hours and actively learn and then retain that, so that when I do have other obligations, I'm not solely like limited to my studying. But I guess just a general synopsis of this presentation: if you actively learn and you understand like where like we have our downfalls, where we're not doing spaced repetition learning, where we're not actively learning, we can honestly like revolutionize our schedules and make the most of like every single minute of the day. If you have any questions, I'm more than happy to answer them.
Hey, should we thank Warren first for
Thank you guys for being here. Naga, you had your hand up?
Yes. How would you recommend like studying with a partner?
Oh, okay.